Good morning, everyone. I'm Vincent Pronod, Sales Manager at Axiom Optics, and I would like to welcome you to our webinar co-organized with Axiom Optics and Symetrie, from high-energy physics to modern production lines, an overview of Symetrie hexapod solutions. In a couple of minutes, I will let my colleagues from Symetrie giving you an introduction about Symetrie hexapods, both standard and custom solutions. But in the meantime, I would like to give you a brief introduction about Axiom Optics, the US and Canada distributor of the Symetrie hexapods. Axiom Optics is a small company of about 10 employees. Most of us are sales engineers. We've been created about 15 years ago, and we are a US-owned small business. And we are very proud to count more than 1,000 customers between the US and Canada, both corporate, government, and universities. We are headquartered at Grantham Labs in Somerville, Massachusetts. But we also have a presence all across the US. And what I want to specify in this slide is that we do not split geographically, but more by field of expertise. So for hexapods, if you have any questions, your point of contact should be Philippe Clemenceau or myself, Vincent Pronod. This is our portfolio, and I know it is very dense. So I'm not going to review everything here, but I just want to draw your attention if there is any product or category that pop your interest, please let us know, and we'll make sure to put you in contact with an expert. And without further ado, I would like to introduce my colleagues from Symetrie, Alexis Arcana, Sales Manager, and Dr. Johan Lamoury, Software and R&D Manager.
Hello.
Alexis and Johan, the mic is yours.
Yeah, sure. Do we have to present our deck? Yeah. Oh, it's not working. Just a few minutes.
Mm-hmm.
Okay. So I will just introduce a little bit Symetrie, who we are, and our way of working. So I will do a quick introduction, and after that, I think the most interesting things is to let Johan present you a little bit more our product portfolio, and after that, some reference also. So with Symetrie, so we are a company based in south of France. So this is 8 p.m. in France now. Our headquarters is in Nîmes. We have been created by 2 engineers from the LNE, so this is the equivalent of the NIST in USA. In 2001, we are hexapod specialists, as we manufacture some positioning hexapod and some motion hexapod. And we are around 50 employees in 2024 for a turnover of around 11 million euros. So our strength is that we do everything in-house. What I mean for the engineering parts, so we do the mechanical design, electronics parts, and also all the software, from the development of the low code, all the algorithm to the GUI. So we can customize it a lot, and we will present you some reference in relation to the customization just after. We do the mechanical assembly, and we also have our own facilities for all the measurement and instruments with CMM, laser interferometers, trackers, and a lot of things. So if we have to measure something different, we can do it by ourselves and certify the performance of the positioning system. As told before, so we have 2 main range of hexapods: the positioning hexapods to positionate something really precisely, and the motion hexapod. So the goal of the motion hexapod is to reproduce a dynamic scenario, a ship motion, for example, or a lot of things. In this case, and regarding the context of today, we will focus on more the positioning hexapods. So the USA, I think, is the first export country of Symetrie. So we work with some really well-known company in USA. So Raytheon, Inmarsat, Meta, Google, NASA, for example, Ball Aerospace, Planet Labs. So a lot of really interesting company. with some really complex and good project for us. So I will introduce shortly also what's the Hexapods technology. So we always compare the Hexapods technology, so the parallel robotics, to serial robots. So what's the strength of the Hexapods regarding this kind of stacking of degrees of freedom is that you do not accumulate all the errors from 1 degree of freedom when you stack. You have natural good repeatability, really high resolution and accuracy. You have an equal repartition of the mass in each of the 6 actuators. So you can put from 5 kilograms up to 20 tons, really depending on your use case. But this is a scalable solution. You can achieve the 6 degrees of freedom with a configurable pivot point in the space. So you just control the Hexapod with in Cartesian mode. So the kinematics model will do the movement by themselves. They have an easy cables in movement when you have like always a lot of things in the laboratory or in the project. So this is easier to manage. And I think that's all. Our way of working, just to go a little bit deeper inside how we work. So as I said before, so we do everything in-house. So we have the positioning and the motion Hexapod portfolio available on our catalog, on our website, or you can freely consult Axiom to have some soft counsel about it. But we also have all the research and development team and all the knowledge in-house, so we can customize it a lot. So we try to start from an Hexapod to adapt it regarding the specification, but we can also do the system that you need regarding some very constraintful specification. So we will show you some reference after. So we will focus on the positioning Hexapods. With the positioning Hexapod, so we will position something really precisely with small resolution, high repeatability and accuracy. So we have start from the millimeters, microns. Now we try to search the nanometer, and we are not very far. So I will let Johan talk about it.
Thank you, Alexi, for an insightful presentation. Let me now take over and continue our discussion focusing on our standard positioning hexapods. Let's start with the Solano. So Solano is our smaller and latest released hexapod. It's very compact. It's 100 millimeter and 104 millimeter high with absolute encoder and brushless motors. It reaches 0.1 micrometer of linear resolution and 2.5 microradian of angular resolution, which is quite impressive. It's been designed for production and assembly lines mainly. Moving to the Mocha Hexaglide. On almost every slide, you'll see some specification and key features on the left, and you'll have some showcases on the right. So Mocha is 0.5 micrometer of resolution and 5 microradians of angular resolution within a small diameter of 107 millimeters, which is very interesting. And it has a nice travel range along the z-axis that you can see on the screen. This hexapod on the right is an optical ground support equipment aiming at positioning a space telescope, an M2 mirror, for calibration and gluing process.
Yeah, this one have been delivered to Thales Alenia Space.
Yeah,
we have delivered more really soon.
Let's continue with the Bora hexapod that has higher payload capacity of 10 kilograms and still has a very high resolution of 0.1 micrometer and 2 microradian. On the left, you can see an optical application where the Bora is moving mirrors in a high vacuum environment. Then here is the Puna, our most affordable solution, and yet can still reach linear resolution of 0.5 micrometer, and an angular resolution of 5 microradian. This version is very easy to customize, as you can see on the top right of the screen. So it's very easy for us to change the base, the platform, the travel range, or to adapt actuators.
Yeah, for example, in this reference that you can see on the top right, so we have designed this customized Puna hexapods with a flatness of 2 microns to put directly some mirror on top and to do all the qualification and the VNV process for a well-known company in other country.
Okay, moving on, the Breva hexapod. So it fits many applications such as satellite testing that you can see on the top right, or cyclotron integrations, bottom right. The Breva reaches 0.5 micrometer of linear resolution, which is very nice, and can raise 200 kilograms. It's also equipped with absolute encoders, and well, this is a very one of our best sellers. It really fits many applications. Let's continue with the Sirius. So this one has been designed with a high stiffness and a high payload capacity. It's mostly used for industrial applications, but can also fit some scientific ones, like you can see on the right here. So what you can see on the right is 4 Sirius aiming at moving mirrors in an anechoic chamber for satellite testing. So basically, the flight motors can't hold mirrors into a gravity environment on the ground. So we are well known for this kind of solution, replacing the flight motors on the ground for testing and calibrating mirrors for satellites applications.
Yeah. Just to precise, so we only do some hexapod for GSC testing calibration, but we don't have any hexapod that can go in space, not yet.
Right. So here is our highest accuracy hexapod. It's a Zonda. It reaches high performances using mostly INVAR steel and high resolution linear encoders along the actuators. So in addition with motor encoders, this one is equipped with linear encoders along the actuators here, and that helps the Zonda reach very impressive resolution capacities. So in very specific considerations and a control environment, Zonda can, for example, reach 30 nanometers of resolution, which is very high. And the payload capacity is also very nice, as you can go up to 400 kilograms. So on the right, you can see many applications using Zonda. So for example, for sensor calibration, mirror motion, cyclotron integration, coronagraphy tests, etc., etc.
Yeah. Just to precise a little bit, so this is a flexible hexapod, and we can deliver also many options that is standard in Symetrie. So for example, we have one option called extra temperature range. So we can put this hexapod in a thermo vacuum chamber, for example, from minus 40 degrees up to 80 degrees. This is an example. After that, we can put some copper in the motor for the thermal dissipation. We have also the vacuum option, so up to 10-6 millibar. So a lot of options like this. We can customize the mobile plates. If you don't want to put an interface plate directly to your payload, we can adapt it a lot.
And we're equipped at Symetrie with clean rooms to integrate the assembled hexapod, reaching a high.
Yeah, up to ISO 5. Yeah.
Yeah, up to ISO 5. Okay, so as you can see here, the Joran hexapod is designed for heavy payload and up to several tons. Here are illustrated scientific application with some Omni wheels and granites. So this hexapod exists in 2 versions. The first one is includes very stiff and stable ceramic ball joints if the payload ensure a pure compression. And we also have a second version with some universal joints that allow large angles, so an extended workspace. And that's it. So I will now elaborate on some custom references that we have to illustrate on our capacity to understand the customer needs and to design unique solutions. Okay, so first, this is a Freya project. So it's the European Spallation Source scientific project. So the hexapod here is equipped with an additional translational degree of freedom onto its platforms, as you can see on the right here. So you have a standard hexapod with an additional degree of freedom on top of the platform. It's used as a support for dynamically scanning a sample hit by a neutron beam within a neutron diffractometer. So this one was delivered in Sweden, but sold to UK and German companies for their own testing there.
And so maybe we can go, so we have the time, I think we can go maybe deeper in the main specification and option.
Yeah, sure.
So for example, in this kind of hexapod, so we have designed the linear stage, as we don't find any linear stage that can fit with the requirements of the customer. So what's the approach of Symetrie in this kind of project? So we have the specification and the requirements of the customer. We try to make a matchmaking with an hexapod. If we have to add some additional degrees of freedom, we try to search some solution of the market, because they have some pretty good company that manufacture some goniometer, some linear stage, XY stage, a lot of things. If we don't find it, we can also design everything, manufacture everything with some local supplier that works with Symetrie since a really long time. So we can have the hand on all the lead times also. And we integrate it directly. So what we call integrate is not just the mechanical parts. We also integrate it in the same software. And as this, you can control it in the 7 degrees of freedom. So what I mean is that you have two TY, for example, or you can control it directly in 6 degrees of freedom. So we'll just move if you want to make a movement with the TY. This is only the linear stage that will achieve the movement.
Yeah,
for example.
You can change at will the way you want to control your multiple degree of freedom system. So we do the math, or sometimes users want to control directly the extra degree of freedom. That's also possible.
And in this kind of project, we also can give the API if you want to design your own interface and put it in your system. So this is something that we can provide.
Yep. Completely. So it's a nice transition. As Alexis, my colleague, said, sometimes customers just cannot find any good equipment to fit their needs. So that's the case here of this hexapod mounted on a gimbal. So the end user couldn't find any gimbal fitting his needs. So we designed the whole thing. That includes a Zonda, as you can see here, and the Zonda is assembled on a gimbal. So you have a total of 6 + 2, 8 degrees of freedom. This is for the Plateau, which is the Plateau mission. It's a quite interesting satellite equipped with 36 cameras. And this system is designed for testing every single pixel of all those cameras. So it's been designed for qualifying the telescope sensors, holding the detector, and scanning the focal plane of every sensor. So yeah, Symetrie took the gimbal part. We designed the whole system, tested in a clean room at Symetrie, and everything is vacuum compatible. Got a small video here. So in addition of this 8 degrees of freedom system, we added a collision detection sensor that you can see on the tip of the end effector. It's made of spring and helps the detection of collisions between the hexapod and its environment. We also designed some counter masses to masses that you can see on the rear to counteract the mass payload and equilibrate the mass seen by the gimbal. A very interesting project. Okay, let's move on. A quite complex and very interesting machine. So this system has been delivered in France. So the purpose is to design a detector for a very compact X-ray system. I can show you what the system looks like on this video. So the granites are moving thanks to high torque motors and hair bearing. The first zonda, as you can see on the left, holds monochromator. The second one is equipped with an additional C-axis that you will see in a second to hold the sample. And in the at the end of the system, you can see an extra granite rotating at the moment. So it's rotating around another torque motor for moving the detector. So here at the middle, you have torque motors. The granites are compensated with hair bearing. You can see here the additional C-axis for rotating the sample during the X-ray projection. And on this final component, as you can see here, you have a goniometer and a detector for getting the particle at the right place during the motion.
I think it lagged a little bit, maybe in USA, but we have this video on our YouTube channel, for example. So if you want to review it with a more comfortable connection,
you can, yeah. Moving on, a complex satellite application. So this project was delivered at the very beginning of 2024, so this year in February. So the purpose here was again to replace the motors, the flight motors for ground testing. So this system, you can see that there are 4 of them. They're composed of one standard Breva mounted on a rotative and translating tables. So 8 degrees of freedom per system. The main purpose is to replace the motors during the ground testings to be able to reproduce the motion of the mirrors in space. These systems were delivered with a very specific software, a specific HMI to integrate the needs of the customer and for making the software understandable by operators. So it was quite complex because we had several type of control, different motion within different frames. The satellite frame, the mirror frames, the motor frame. So we integrated all of the constraints from the customer and integrated them within our embedded code and specific HMI. Another very, very interesting application within a cyclotron. So we designed the whole system that you can see on the right and integrated on the left, sorry, and integrated at the customer's place on the right. So let's moving on the video to explain what are the degrees of freedom of this system. So we first have a translational plate, a rotational axis, as you can see, moving some very heavy and symmetry design components. You have here 2 degrees of freedom for holding a detector. There. Now here you can see the detector. And finally, we will see at the center of the system one Breva hexapod. This Breva hexapod is itself mounted on additional rotational plate. So you have in the end 11 synchronized degrees of freedom. This is constituting a diffractometer. Every motion are synchronized again and moving around a sphere of confusion of 50 micrometer. So this is very impressive. Everything is synchronized and the sample is always moving within a sphere of confusion of 50 micrometers. So the hexapod, as you might have seen before, the hexapod is holding a vacuum chamber, and the sample is within this vacuum chamber. So we added a door on the rear for the operator to act on the sample, close the door. So we had a bellow, high vacuum compatible bellow, to make it
integrated.
That's it. Okay. So this is a final medley of some of our. It's launching, yeah. So. So this is a medley of our most interesting custom hexapods. So the point of this presentation was to illustrate our capacity to integrate extra degree of freedom to fit the end user needs. So the hexapod counterpart regarding its high stiffness and very high resolution and repeatability is that it has a smaller workspace compared to anthropomorphic arms, robotic arms. So when we need to extend the travel range along certain degrees of freedom, our reflex is to add some extra actuators. We have the capacity to integrate them completely in our embedded codes to control only 6 degrees of freedom but having extra actuators, or to let the user control directly those extra actuators. Here you can see another example of integration onto the platform. So this is a Zonda hexapod having 2 degrees of freedom moving platform on top of the system for space imaging testings.
Yeah, this one is for Leonardo.
This is Go ahead.
This one is pretty interesting also. So this is, so we have put a Joran on vertical orientation. So you don't have an equal repartition of the mass with the gravity vector. So in a vertical orientation, so the hexapod is able to handle around 3 tons. In horizontal mode, to handle around 1 ton. So they are used. This one has been used to qualify and to do the VNV, the testing of some mirrors of 1.8 meter of diameter and 1 tons. And we have added to the hexapod this what we call a chair with a granite to be really stable. We have added a TZ of around 300 millimeters, something like this. So just to give you some rough impression about this one. So the ACE is around 2 meters. 2.4 meters.
The height, yeah. And it's hard to see indeed, but there is an extra vertical axis for moving the whole system.
Yeah.
So the purpose here is to handle this mirror to qualify a sensor which is quite far away, and the system is able to point every single pixel of the sensor.
And in the vacuum chamber.
The whole thing, of course, in the vacuum chamber. So this is a very specific project. It's a patient positioning share for medical application. The system is quite complex too. We have first a translation of the granite, then we have a Z elevation table, a rotation axis, and then we have an hexapod on top of that. So it's about 9 degrees of freedom, and the aim is to position this patient in front of some beam in a cyclotron. Yeah, so
we have seen this one.
We have already seen this one. Yeah, it's a very nice realization of symmetry. Almost everything is in INVAR, vacuum compatible, very impressive resolution. Yeah, we saw that too.
Yeah. So I think the goal of today is just to show you rough example of our standard portfolio, to present you a little bit the company, some standard product, but also some custom design that we can achieve. So since 20 years, so we have a lot of different projects in positioning project. So if you have any question or you are interested to have more and deeper presentation, this is with pleasure. So if you want to add something.
Yes, are we going through the HexaSym presentation?
Yeah, sure. Of course, yeah.
So we will show you a software that we use for all the, how to call it, preliminary project.
Yeah.
Simulation project, yeah.
I'll take it from you. So this software is downloadable from our website for free. Okay, so you can just go to symetrie.fr or even .com, and you will be able to download it on any computer. So the purpose of this simulation software is to let you choose any standard hexapod from this list. So you can select a positioning hexapod or a motion one, but let's stick on the positioning one as it's the purpose of this webinar. Let's take, for example, the Zondice here. You can integrate your own environment. So let's do that to illustrate. You can say that we have a CMM under the hexapod. We have a vacuum chamber on the hexapod. Okay, so compared to a robotic arm, it's quite complex to draw and to describe the workspace of a hexapod. So that's the main purpose of this software. So here, every time you consume some travel range on the degrees of freedom of the hexapod, this software will illustrate the remaining travel range on the other degrees of freedom. So let's say that I'm consuming a lot of vertical translation. Here, it's moving. So I have less potential of rotation, okay? So this software lets you drag those sliders to try and test different poses, okay? So it goes a little further. You can use the software to design your payload. So let's say I have 200 kilograms mounted on this Zondice. I have a center of gravity, which is, let's say, 1 meter high. Okay. I'm going to make my model transparent so that you can see the frames. Okay. Let's say I don't want to control the platform of the hexapod, but I want to control a frame which is around the sample up here. So let's configure the pivot point and say, okay, my pivot point is also 1 meter away from the platform of the hexapod. Okay, so now I'm rotating around this frame. Maybe it's a little bit too high. Let's say better. Yeah. 800. Okay, so now when I'm going to rotate the hexapod, I won't be rotating anymore around this, let's say, symmetry platform frame, but around the frame of interest up here. So if I'm moving again around Rx, I will be moving around this point. And the hexapod will travel a lot in translation, as you can see here. Okay, of course, when you change the center of rotation, the point of interest, and that's a very interesting feature of our systems, of course, you're losing some potential of degrees of freedom. And this simulation software helps you visualize what's remaining when you completely configure your use case.
En dehors des limites. En dehors des limites, et upgrade de zonda pour montrer un petit peu.
Tu veux que je monte?
Mets-le dans le rouge pour montrer que les actionnaires sont
So the software also advise you when you exceed some limits. Okay, if I'm asking for an impossible motion to reach, the software will inform you about the cause of the configuration problem. So here we are exceeding the factory machine workspace and actuator limits too. You can also design some, let's say, too high masses for the system, and the motion simulation will tell you when you can move this mass or where you can't. So in this case, I can move within this workspace 450 kilograms without any problem. Vincent, do you want me to add something, or maybe it's time for becoming more interactive?
Yes, and thank you so much, Alexis and Johan, for the presentation, and two, for the short demo of HexaSym software. Just to clarify everything, HexaSym is not a control software; it's a simulation software. So this is something that we use internally to qualify a project when you share with us your specs. But this is also something that you can use yourself. As Johan mentioned it, you can download it from Symetrie or Axiom Optics website. when you go through the specs, for instance, just for the Zonda or the Zonda S, you just run this case. So I'm going to emphasize on it. When you go through the brochure for the Zonda S, or for the Zonda, it says it's limited to 400 kilograms. But as you can see here, you can actually set up a payload of 450 kilograms and play a little bit with the travel range. You will still be allowed to do some small movements, even though you are exceeding the maximum payload indicated in the specs. So, sorry. So this is a very useful simulation tool. Okay, so now let's move on to the questions. Again, if you have some questions, now is the time. You can write them in the chat, and we will answer them. We already received a few questions. The first one was, if I may say so, a practical question from Patrick Thompson regarding sharing the slides. We can share the slides individually, so please feel free to reach out to us after the webinar. And in any case, we'll share the recording of this webinar with all of you. There was another question from Patrick Thompson regarding high-load hexapods. So that was at the beginning of the presentation. We haven't covered it yet. But long story short, if you're looking for a payload above 100 kilograms, you should be looking at the Breva, the Zonda S, the Zonda, the Sirius, the Joran, etc. There was also a question about the horizontal position. So what we call the standard position is the vertical position, the hexapod basically in that position, and what we call the horizontal position is the hexapod in that direction. In horizontal position, the mass of the payload is only supported by a few actuators. And so basically this reduces the maximum payload you can mount on the hexapod. The rule of thumb is this will reduce your payload to 40% up to 50% of the maximum payload. So let's say that for the Zonda, the maximum payload is 400 kilograms. In horizontal position, you will be limited to 140, maybe a little more, but yeah, around 150 kilograms.
After that, yeah, it will really depend also on the center of gravity of the mass. If you have a pretty long offset, you will reduce a lot the payload capability of the hexapods. So this is why we try to always study the use case with you when we are in the preliminary design phases, to study that this is the good hexapod and you will not receive something wrong for the project.
We have many hexapod set up at the horizontal or even upside down on some applications. So it is something that we can do without any problem, but requires some consideration and some exchange between you and Symetrie. Yeah.
And yeah, Axiom Optics.
And Axiom Optics, of course.
There was a question from Christian Napoli about the resolution of the hexapod. So I think the confusion comes from the fact that at the beginning of the presentation, Alexis, you mentioned that now we are tackling the nanometer scale in terms of resolution. So for the standard products, the hexapods with the finest resolution are the Solano, the Bora, the Zonda, and the Joran, and they are reaching about 100 nanometers resolution. Can you maybe, Alexis and Johan, do you want to develop on finer resolution, maybe work that you've done toward that direction?
So we have the specification of all the hexapod in the datasheet. So up to 0.1 microns, for example, for the Solano or the Zonda. After that, in some really specific application, we can optimize some parameters in the hexapods on the mechanical part to optimize the resolution up to 30 nanometers, but in some really specific condition. What I mean is that we have exchange with the customer, and you have to have really stable temperature, not of external
very stable ground, controlled environment in terms of humidity and temperature. But we can do it. We can reach few nanometers. It also requires some very specific measurement systems. So we have some at Symetrie, but measuring the nanometer requires very specific setup.
Yeah, just for example, with this, we have done an hexapod also in 40 nanometers. So this is a Zonda S hexapod for synchrotron applications. And so when we do all the measurements, so we put the hexapod, the payload on top in the chamber. And after that, when they have a truck on the road, just next to the synchrotron, you see all the movements. So this is really thin, and we have to have all the parameters really stable to do this kind of measurement, but we can achieve it. Yeah.
There was another question from, I think it was Phil Mackey, about the differences between motion and positioning hexapods. So the wording we use, basically positioning hexapod, they are the same technology, but positioning hexapod will have much finer resolution and much better accuracy. They will also be slower. Motion hexapods are, as it says in the name, used for motion, so basically for simulation, and they have therefore much higher speed and acceleration specs, but not the same level of resolution and accuracy than positioning have. So really two different kind of applications, also two different ways of driving the hexapods.
Yeah. So motion hexapods have completely different dynamic features. So this one, for example, the Mistral is one of our most sold motion hexapod, can reach 1 G of acceleration and about 1 meter per second at the actuator level. So they are pretty dynamic systems that can move, thanks to their stiffness and repeatability, high masses with dynamic motion. So they're mainly used for reproducing some data, acquired data, or trajectories created by users for helicopter flight, boats, ground vehicle simulations, moving submarine elements into water. So the application is completely different. The purpose is to transmit, to reproduce dynamic motions to an object.
Yeah.
But the technology is quite similar. It's still a parallel kinematic machine. It's still an hexapod, but basically the gear ratio is very different. So we are looking for dynamics.
Yeah, just maybe to add something. So you can see a lot of hexapods. So the hexapod is a wide market. You can see a lot of hexapod used for what we call entertainment. So to drive a car, to simulate something. This is not the positioning of Symetrie. So we come from some scientific project. This is an engineering company. And so we have some pretty high resolution hexapod for a motion hexapod in a 1G with a 1G acceleration. And we also have some high performance software to follow with a lot of reliability, some trajectories to reproduce some dynamic scenario, to also test some antennas in real situation, something like this.
We illustrate a lot of use cases on our website, so don't hesitate to go there. We have two different pages, one for the positioning system and the other one for the motion systems, and we have many examples, so you can have illustrations.
Yeah.
I want to add something to that, which is that the Solano, which is actually a positioning hexapod, is actually pretty fast. So I know it's not fitting exactly the description I gave earlier, but so basically the Solano is widening for production lines, and therefore speed is a requirement there. So it's pretty fast. It's small, very compact, doesn't accommodate very high payload, but it's pretty fast. And there was, I think so far, there's a last question, which is from Jeffrey Mead about the vacuum compatible hexapods. So right now, the only high vacuum rated hexapods are the Bora, the Zonda and the Zonda S, and the Joran. Am I forgetting anything?
No,
we will have soon, like at the end of the first quarter, a Breva hexapod, smaller version. This is still an R&D compatible with.
We're working on a compact vacuum compatible Breva.
Yeah. So if you have any requests, we can study it, but not in short term with 6 weeks of delivery time.
No, it will be released in 2025 next year.
Somewhere the middle of 2025.
Yeah. So right now, for high vacuum applications, the Bora can work with payloads up to 10 kilograms. The Zonda S and Zonda payloads up to 400 kilograms. The Joran for payloads up to 1.5 ton. And soon the Breva for payloads up to 200 kilograms, filling a gap between the Bora and the Zonda.
Yeah.
So just for you to know, if you're using HexaSym as I'm displaying here, when you switch from one hexapod to the other, you have a button for asking for the maximum payload that the system can accept. Okay, so you can start your choosing with this parameter. Say, okay, I do have well, let's say 1 ton and a half, like here. I'm starting with a Zonda S. Okay, the software will tell you that Zonda S cannot hold this payload. Okay, and you can just roll into this list until you can find the most compatible hexapods regarding to the mass you entered. Okay, so yeah.
There is
so an example. So we don't have described the Sures hexapods. Maybe you can show it. Just few comment about this one. So we don't have presented this one because this is a specific hexapod that we use to support mainly M2 mirror in some optical telescope.
Yeah.
So this is to compensate all the deformation and the movement of a telescope to stay with a focal point at the infinite. So this is specific one, really stiff, with smaller movements.
Very stiff, very reliable, and very repeatable, with a very high payload capacity, but a very small workspace too.
Yeah, but this is not the use case. So
we have lots of this system in America on big telescopes. North America, Canada, United States, Mexico. Yeah.
There is a last question from Patrick Thompson regarding the design and the manufacturing of the hexapods. And so to answer your question, yes, they are being done in France. So yeah, design and manufacturing is being done in France.
Yeah, everything is doing where we are standing right now in south of France.
And we have a brand new building. So if you want to come with Axiom Optics to visit our factory and to do a factory acceptance test of the hexapod, this is always with pleasure.
So we have specific assembly lines for positioning systems, for motion hexapods. As I said, clean rooms, different level of clean rooms, metrology chambers. Everything is done here.
Okay, I think this was the last question. So unless a question pops up right now, I think we'll call it a day. I mean, at least for our friends in France, because it's pretty late for you guys. So thank you for making it.
Thanks to you and thanks to everyone.
Yeah, I hope this
will
be
the organization of the webinar.
We'll follow up with the recording. If you have any questions, please feel free to reach out to us, and we'll be happy to assist. Have a good day.
Thank you, everyone.
Thank you. Have a good day.
Have a great day. Bye.
Bye.